They're some of the most powerful and, let's be honest, spectacular events on our entire planet. I mean, they can build whole islands up from nothing and then bury entire cities in an instant. We're talking about volcanoes, of course. And in this explainer, we're going to break down exactly how these fiery architects shape our world, literally from the inside out. I mean, just look at this. This is raw planetary power on full display. It's beautiful, and it's absolutely terrifying all at once. But to really understand what's happening, we have to go deeper, way deeper, to the invisible forces at work far beneath our feet. So the big question is, what turns a quiet mountain into this? Let's dive in. All right, so our journey starts thousands of miles below the surface. And maybe the best way to picture our planet is to think of it like a gigantic cosmic pressure cooker. Seriously, deep down in its core, there's this immense heat, and it's constantly building up pressure that has to eventually go somewhere. Now, scientists have a name for these internal engines. They call them endogenic forces. It's a bit of a mouthful, I know, but the key part to remember is endo, which basically just means from within. These forces are born in the planet's fiery gut, and they're the single starting point for every volcano on Earth. So it all really boils down to two primal forces. First, you've got the incredible blistering heat that radiates out from the Earth's core. It's so hot it literally melts solid rock. And second, as all this new molten rock, or magma, starts to build up, it creates this unimaginable pressure. You know, it's kind of like shaking up a can of soda. That pressure is desperately looking for any weak spot to burst right through. Okay, so you've got all this immense pressure with nowhere to go. How in the world does it get out? Well, it finds the cracks. It seeks out the weak points in Earth's thin, brittle outer shell. You see, the surface of our planet isn't one solid piece of rock. Not at all. It's actually a giant, slow-moving jigsaw puzzle made of these enormous slabs we call tectonic plates. And these things are always on the move, constantly grinding against each other in super slow motion over millions of years. And this whole idea, this grand theory, is called plate tectonics. It's one of the most important concepts in all of geology because it doesn't just explain volcanoes, it explains earthquakes, mountains, even the shape of the continents themselves. It's basically the rulebook for how our planet works. And here is where it all clicks together. The edges where these giant plates meet, the plate margins, those are the weakest spots in the Earth's crust. Think of them as geological fault lines. They're the natural escape valves where all that pressure from below can finally punch its way through to the surface. So the stage is set. The pressure has been building for centuries, and it's finally found a weak spot. Now we get to the climax of the whole journey, the eruption. This is that moment where all that pent-up energy is finally let loose. So let's trace its path, shall we? Way down below, the molten rock pools in a huge underground reservoir called a magma chamber. As that pressure hits a tipping point, it shoves the magma up through a narrow pipe, a conduit, and it races toward the surface until, boom, it bursts out of an opening we call a vent. Okay, quick sidebar here, but this is an important one that trips people up. While that molten rock is still trapped underground, we call it magma. But the second it breaks through to the surface and starts flowing, it gets a new name, lava. It's the exact same stuff, just in a different location. But here's the thing. An eruption isn't just that classic slow-moving river of lava. Oh no, it is a violent, chaotic cocktail of stuff. You've got superheated steam and poisonous gases like carbon dioxide billowing out, and you've got tons of solid material getting blasted into the sky. Everything from fine, choking ash to massive boulders of rock that scientists call pyroclasts. So, once the eruption is over and the smoke clears, what's left behind? Well, this is where volcanoes have this really fascinating dual legacy. They are forces of incredible world-building creation and also of terrifying destruction. Let's start with the good side. On the constructive front, volcanoes are true world builders. The lava they spew out cools and hardens to create entirely new land. Think about the islands of Hawaii, for example. The ash, while it seems destructive at first, eventually breaks down and creates some of the most fertile soil on the planet. We even harness their power for clean geothermal energy. But there's always the other side of the coin. And the destructive power is just staggering. A single big eruption can literally wipe cities off the map, burying everything under tons of hot ash. It can trigger deadly floods and tsunamis, and it can pump so many poisonous gases into the atmosphere that it affects the climate for years to come. Okay, so we've got the how and the what. Now, let's zoom out and talk about the where. Where on Earth do we actually find these hotspots of volcanic activity? Well, what's really fascinating is that volcanoes aren't just scattered randomly across the globe. The vast majority are concentrated in this one massive horseshoe-shaped belt that circles the Pacific Ocean. And this zone is so active, it's earned a very fitting name, the Pacific Ring of Fire. And you know what? That name is no exaggeration at all. Get this, a staggering 80% of all active volcanoes on Earth are located right here. 80%. That is, by a huge, huge margin, the most geologically violent and active place on our planet. Now, the Ring of Fire is definitely the big one, but it's not the only spot. There's another major zone called the Mid-World Mountain Belt, and this is where you'll find some of the most famous, or maybe infamous, volcanoes in history, like Mount Vesuvius and Mount Etna over in Italy. So in the end, we're right back where we started, with this powerful two-sided nature. Volcanoes are capable of such incredible destruction, there's no denying it. But at the same time, they're a fundamental creative force that has shaped the very ground we stand on. So it kind of leaves you with a big question, doesn't it? Should we see them as the villains or as our world's essential architects?